converting WASD into a vector and slapping it into your velocity is cool, but have you seen actual games? Try open basically anything 3D and mash A and D keys fast to see the result. What you'll see is dependent on the game, but I can almost guarantee you won't see this. Let's also jump and then run left after the landing. Watch the head, it travels like 40 centimeters in a frame. Let's fix this behavior. In real life, object's velocity never changes instantly. If it was something then the opposite, it means that either it gradually slowed down then flipped and grown to the opposite direction, or it saved the speed but quickly turned around. I don't like linear vector interpolation for movement, but the video too short to explain why. Think of these two cases I'm showing on the screen. Saving speed while gradually changing its direction, on the other hand, is much more real-life-ish. So instead of taking WASD direction and overwriting our speed with it, we will just rotate it. First we calculate the direction input wants us to run, then character's face direction and the difference. Then if the difference is bigger than some angular speed value, we rotate our vector by the angular speed. If not, we rotate it by difference, compensating it. Better already. At least it passes the spam test and the head test. But I want more control, and I also bet there are people among you who are questioning the code because this construction could be a single clamp function. This is not a clamp, because I want different functional from these branches. Think of real life again. Creatures that value their lives usually drop the speed at the turns, so what I want to do is to create another variable for controlling the speed inside the turn. Now we have angular velocity that regulates the time interval in which the turn will happen, and the turning speed that regulates the turn circle radius. If you don't like the radius at all, but want to have not instant turning, you can set turn speed to a very low value. This way you can have the character that is either running or turning, like they do in Dota for example. Play with the parameters as you want. My personal preference is that turning speed will be about 60% of full movement speed. Now my favorite part, implementation problems and enhanced road for the future. Problem number 1. Run in a direction, then input the opposite movement vector and jump in short. Player doesn't obey the command. Well, actually it does, it just the command is stupid. Currently our jump just yeets the player into the air and the velocity direction is saved. It means that if the player was turning at the moment of the input, it will jump mid-turn. Here's several solutions I can see for this problem. Have it as is, just create an ability to turn in the landing states too. This way the strange behavior will be preserved, but much less noticeable as player doesn't have this short animation stun lock of the landing. You can add this turn functionality into the jumping up animations as well. This way we achieve almost this result. You can straight up forbid the jumping for some cooldown after the landing by creating a flag able to jump in the resources and validating input with it. Or, if it's too nuclear, you can have a flag for turning in your running state. This way the running state knows if it's turning in the frame or not. Then you can just forbid jumping during the turn aspect of the running state. Or you can not forbid the jumping during the state, but to save the jump command into a queued action, redefine the accepts queuing and transitions to queued getters as unique for running states way. Instead of backend animation, just modify it directly if the player is turning or not. This way you can queue actions during the turn and unleash them after it's finished. But, if you need one such custom behavior processing like a jump, you can perfectly live with this is-turning boolean flag in your run. The moment you started to think of all these custom queuing behaviors, or you want to straight up prohibit something during the turns, it is a sign from single responsibility principle gods above that you need another state, the turning state. In that state, you can redefine the shit out of your mechanics. Talking about states, my run code is still very similar to the sprint code. The difference is in the constants. If you plan to sweat, create a turning move as a scene with exported variables for turning. This way you can instantiate two turn moves with different animations and parameters, but with one code. Also, states embracing opens us the door to sexy techniques like this lock and turn from the Dark Souls. Specifically, if you sprint and then want to make a turn that is too sharp, you can transition to this pivoting animation and load the player there for some time to think about his movement decisions. Second small problem is this inconsistent pivoting directions. The reason is the game splits the world evenly between minus 180 degrees and plus 180 degrees, with precision where float values in the move and slides are starting to define your future rotation drastically. Actual industry answer for spamming turns ruining aesthetics is to tell you to stop spamming turns because they couldn't care less. If it is bugging you that your character doesn't turn consistently, the way to fix this is to implement a custom signed angle difference function function that splits your world in another way, for example 178 to 182. And the last topic I want to talk about is the spamming of turns while moving. If we are sprinting forward but start to wiggle, we are sprinting with full sprint animation, but actual speed of the character is the turning speed of the sprint, which is much lower and awfully similar to simple run speed, and our sprinting legs aren't consistent with it. You might think that the way to fix this is again to make turning a separate state, but the better fix is to better understand what the speed of the character even means for the legs animation. This section is inspired by this comment from a while ago. The mechanic is very deep and is one of the Thanos snaps that instantly give your movements more professional look. I will certainly create an in-depth tutorial about it sometime, but I also want to mention it here. As your turn speeds are different from running speeds, you can scale down the animation speed to match the legs. If you want to do that, add this code to the end of your updates and don't forget to return the speed scale to 1 on exit. This is a temporal solution and I want a better system to manage these things in the future, so write it down somewhere where you document technical depth.